All right, I'm going to make a couple of videos on the geometric mean. The first one is just algebraically how it's done, and the second one I'll show visually what it looks like and where it comes from. So you definitely want to do this one first, get the process down, so when I talk about the visual, it'll make more sense. And this will make more sense if you do watch the visual, like what does geometric mean actually represent. So first problem I have here is what is the geometric mean between 4 and 9? This is a question that pops up once in a while in math counts, sprint rounds, or countdown rounds. Pretty quick problems. When you set these problems up, you're going to set up proportions. You're going to put an unknown variable x or whatever for the geometric mean. It's basically set up like this. Geometric mean is diagonal from itself. And then the other two spots will be filled in with your numbers. Now it doesn't matter if I usually set it up like I did over here or like I did with the x's on the opposite sides there, but they have to be diagonal from each other. So what is the geometric mean? Xx between 4 and 9. Just put the 4 and the 9 in the other two spots. So when you cross multiply, you'll get x squared equals 36. Now here technically you have two answers. X could be 6 or negative 6. This is a geometric mean problem, which means it represents length of something. So all we're going to do and all I'll pretty much talk about is the positive length. So 6 is going to be our geometric mean. Okay. Our next one, what is the geometric mean between 8 and 20? Go ahead and do that one right away if you'd like to give it a shot, if you already remember it from the last problem. And then pause it, but I'm going to go through it right away. So what is the geometric mean? So I put that kitty corner because I don't know what the geometric mean is. Between 8 and 20. Cross multiply. And then take the square root of 160 for my answer. Now, algebraically, there's two answers, but we're only going to worry about the positive answer. The square root of 160 is somewhere around 12.6. Simple enough. What if you know the geometric mean and you want to know one of the other numbers? So 15 is the geometric mean. Well, that means I'm going to do it this way. Between 10 and what number? So the only unknown I have is the what number part. Cross multiply and divide by 10. Okay. Now, an algebraic mean is halfway between the two numbers. A geometric mean is kind of like that. It's some kind of an average, but it's physically in some shape. It's a triangle that I'll show you later in the other video. But it's in between somewhere, but it's not exactly halfway between. So this number, 22.5, if you put this up here, and the 10 is down here, kind of on a continuum, the 15 is the geometric mean. It's in there somewhere. It's between the 10 and the 22.5. It's just not halfway between, just like the other problems. And we'll try one more, just for some extra practice. Go ahead and do this. 8 is the geometric mean between what number and 30? Pause it if you want. Okay, so I'm going to set up the 8's diagonal from each other because it is the geometric mean. And between what number and 30, it doesn't matter which one I put where. When I cross multiply, I'll get 30x equals 64. I divide by 30. What was that, 2 point something? 2.1. Okay, now you're going to have to, if this was in a countdown round, especially a problem like the first one, let me go back here. If I go back to this one, and I wouldn't actually set these up, these proportions up. You should just kind of be able to do in your head, what does a geometric mean between 4 and 9? I just know I do 4 times 9 in my head real quickly and take the square root. Okay, so if they're looking for a geometric mean, multiply them square root, quick, 6. If I'm looking for the geometric mean for this problem, multiply 160, take the square root of that. You know, maybe they'll ask for it in radical form or something, and you can break that down. So that's the basics on geometric mean. Go ahead and watch the next video. It gets a little tougher in the picture with the triangles, and then you'll understand what it actually physically looks like.